This distance measurement system is centered around an HC-SR04 ultrasonic sensor hooked up to an Arduino MCU. It returns a dimension of a given test object placed within the apparatus in millimeters upon applying the calibration equation. The sensor retrieves the raw data from the test object in the form of time in microseconds at which it takes the ultrasonic waves emitted by the sensor to return to its receiver. The signal modification system is the linear relationship between time in microseconds for the 40 kHz acoustic burst to return to the sensor's receiver and the distance in millimeters of the object. This relationship is modeled by the calibration curve and applied using the resulting equation. The Arduino Uno R3 serial monitor acts as the indicator. In order to measure a test object, the test object must be placed ahead of position 0, indicated by the raised ridge along the width of the measurement surface, while the slider is placed against the object. The algorithm is set to consider only the dimension of the test object through subtracting the sensor reading from a predetermined reference distance. The test object utilized here is an Energizer AA battery, which has industry standard known dimensions. So the first dimension taken is the diameter of the battery. The known dimension is 14 millimeters. The battery is placed between position 0 and the slider. The calibration equation is applied to the duration value, which is in microseconds, to return the calibrated distance, which will be in millimeters. It is now time to observe the serial monitor. The output value is 15 millimeters, which is slightly higher than the true dimension of 14. Now that the diameter has been recorded as a measured value, the second dimension we'll take is the length of the battery, which is known to be 50 millimeters. The battery is placed between position 0 and the slider along its length. Upon applying the calibration equation, the output distance appears to be 50 millimeters, which equals the expected value. This table shows the known dimensions compared to the measured values in conjunction with the maximum uncertainty range. Note that due to the precision limits of the ultrasonic sensor used, accuracy down to parts of a millimeter cannot be shown in the measured values. Adding or subtracting the maximum uncertainties to the measured dimensions shows that the measured dimensions are within reason of the known dimensions, as the known dimensions fall within the uncertainty range of the measured values. Overall, there are some improvements that could be made to reduce the uncertainty window, or reduce the random error observed in the investigation, which are outlined in the conclusion and recommendations of our summary report.